Thank you very much, Catherine. For those of us of my generation, the prospect of dementia is one that we hope you manage to solve, or the problem is one. There are a series of grants in the area of Parkinson's disease, the first of which went to Dr. Haydn Allbutt of the University of Sydney. Haydn, if you could tell us briefly. Thank you.
Once again from me, thanks to the Brain Foundation for funding this work. Now, one of the most effective treatments for Parkinson's disease to date is dopamine replacement therapy. But it, in addition to various experimental treatments which have made it to clinical trials in recent years, has been found to be unable to either stop the disease or, in many cases, to slow the disease down. And so if you get Parkinson's disease, you will die from it, because there is literally nothing that we can give you that will do anything towards stopping the disease. Now, when I was setting up my lab, what I wanted to do was to direct our area of investigation towards something that hasn't been done before. I thought there was no point setting up a lab to investigate something that 100 other labs were already looking at. And given the state of understanding of our treatments for Parkinson's disease, I was actually quite surprised to find that looking into what causes Parkinson's disease was actually one of the least examined fields. And so that's what I've set up my lab to look towards, what initiates Parkinson's disease and how it's travelling through the brain. Now, one of the very, very earliest pathologies of Parkinson's disease is a misfolding of a very small protein called alpha-synuclein. So what we want to do is to take misfolded alpha-synuclein and inject it into the brain and examine whether it's transported to the targets of the injection site. And once at that target of the injection site, it should then induce all the downstream pathologies that we know make up Parkinson's disease. And that's never been shown before. So we've shown that alpha-synuclein can travel from cell to cell to cell, but is that the cause of Parkinson's disease? Is that what triggering these downstream pathologies? So we're hoping to show that. In addition, one of the proposed ways that this pathology gets into the brain, it's thought that alpha-synuclein in the gut is misfolded and then somehow travels up into the brainstem, probably by the vagus nerve. And so what we're planning on doing is feeding misfolded alpha-synuclein to our animals and examining the brainstem to see if it is indeed transmitted from the gut up into the brainstem, as has been proposed, but which hasn't been shown before. So I'd like to personally thank the Brain Foundation, not only for funding my work, which of course allows me to continue, but for funding research that hasn't been done before and really gives us young researchers a start which will allow us to have a lifetime of work in the field.